Hi everybody, this is doing probability distributions, expected value, and standard deviation. Okay. A random variable describes the outcomes of a statistical experiment in words. Okay, so that is in words. The values of a random variable can vary with each repetition of an experiment. Uppercase letters such as X or Y denote a random variable, and again, it is in words. Lowercase letters like X or Y denote the value of a random variable. Okay, if X is a random variable, then X is written in words, and X is given as a number. For example, let X equal the number of heads you get when you toss 3 fair coins. The sample space for the toss of 3 fair coins is tails, 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 so on and so on. So you can have 0 heads, 1 head, which is here or here, 2 heads, here, 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 or 3 heads right there. Okay, so this right here are your values, the little x, and x is the number of heads you get when you toss 3 fair coins in words. Okay, they are countable outcomes, and you can count the possible values, so you can x is a discrete random variable. That's what discrete means, is it is countable. Okay. Probability distribution function for a discrete random variable. Here's your definition. A discrete probability distribution function has 2 characteristics. Each probability is between 0 and 1, includes 0 and 1, and the sum of the probabilities is 1. So if you are checking to see if you have a discrete probability distribution function, then you would add these all up, make sure they equal to 1, okay, and make sure each of these is between 0 and 1. All right, here we go. This is a hospital researcher is interested in the number of times the average post-op patient will ring a nurse during a 12-hour shift. For a random sample of 50 patients, the following information was obtained. Let X equal the number of times the average post-op patient will ring for the nurse. And this will, what he got was 0, 1, 2, 3, 4, or 5 times out of the 50. So this right here, easy way to find percent. If this is 50, just multiply by 2. So that would be 8%, which is 0.08. Times 2 is 16%, 0.16. That's 32%, 28%, 12%, and 4%. Oops. And 4%. So, all of these are between 0 and 1. And if I add them up, 0.8 and 16 is 0.24. I got the 32. 28 and 12 is 40. And then the 0.04. 8, 10. 2, 3, 6, 10. So, that does total 1. The sum of the probabilities is 1. So yes, that would be a probability distribution function, a discrete probability distribution function. Okay, the next example we've got, a child psychologist is interested in the number of times a newborn baby's crying wakes its mother after midnight. For a random sample of 50 mothers, the following information was obtained. Let X equal the number of times per week a newborn baby's crying wakes its mother after midnight, and the values of that, little x, equals 0, 1, 2, 3, 4, 5. All right, again, it's 50. So if we want a percent, you just multiply the top and the bottom by 2. So I'm going to have 0.04, 0.22, 0.46, 0.09, times 2, I forgot to do that. So, times 2, 9 times 2 is 0.18, 4 times 2, 0.08, and 1 times 2, 0.02. Okay, so, you can, of course, get a calculator. You don't have to do it by hand like I did. Pretty basic calculator will do it. Let you just add them up. 0.18, 0.08, 0.02. And so it meets the second thing. All the probabilities add up to 1. Okay. All of these are between 0 and 1, so it checks off both. It is a discrete probability distribution function. Okay, so we're going to set this up ourselves. Suppose Nancy has classes 3 days a week. She attends classes 3 days a week 80% of the time, 2 days 15% of the time, 1 day 4% of the time, and no days 1% of the time. Suppose 1 week is randomly selected. Let X, large X, equal the number of days Nancy attends class. Okay? So that's the solution on that. X takes on what values? Well, that would be the little x, be 0, 1, 2, 3. Okay, so suppose 1 week is randomly chosen. Construct a probability distribution table, called a PDF table, like the one in example 4. Okay, well, I could insert a table if you like, or I could just write one down. X equals 0, 1, 2, 3. And the probability of X, so I'm going to have the probability of X equaling 0, is 1% of the time. So that is 0.01. Probability that X equals 1, 1 day is 4% of the time, 0.04. Probability that X equals 2 is 15% of the time. And the probability that X equals 3, she attends all of the classes, is 80% of the time. This table should have 2 columns and labeled X and P of X. What does the P of X column sum to? Well, that's 5, plus 15 is 20, plus 80 is 1. Okay. So, that is, well, I've got one more example of that, and then I'm going to stop this recording. Jeremiah has basketball practice 2 days a week. 90% of the time he attends both practices. 8% of the time he attends... Okay, Jeremiah had basketball practice. 90% of the time he attends both practices. Alright, so what is X and what values does it take on? X is number of times he attends. Okay? It takes on the values 0, 1, 2. He's got 2 practices a week. All right, 90% of the time he attends both practices, so that would be 0.90. 8% of the time he attends one practice, and 2% of the time he does not attend either practice, 0.02. All right, so we've got the values it takes on, and 98 and 2 would be 100, so 1. It does, in fact, add up to 1. On the next slide, we are going to start with expected value, which is called mu. Okay, pronounced mu. Simply multiply each value of the random variable by its probability and add the products. So that's the end of video 1.